Hello, this is Susan Potts, and I'm going to talk with you today about simplifying radicals or simplifying radical expressions. And so there are a couple of properties of square roots that we need to talk about briefly. So if you're working with, remember this symbol is the radical and this is the radicand. If you're working with a radicand that can be split into two factors or more than two factors, one of the rules of working with radicals is that you're allowed to split those into two separate radical notations. And the same thing is true for the square root of a fraction. You're allowed to take that and split it into the square root of the numerator, and then your division symbol, and place that over the square root of the denominator. So you're going to see me using those techniques as I work through some of these examples with you. So the first one is a pretty simple example. The square root of 144 is 12, and I don't think I need to do any more than that. And the reason it's 12 is because 12 multiplied by itself, or used as a multiplier twice, brings us back to the radicand 144. So let me use the second rule here. I'm looking at the square root of a fraction or a ratio, and I'm going to split this into two parts. The square root of the numerator over the square root of the denominator. And now I think you can see that as we take the square root of 49, which is 7, and the square root of 36, which is 6, then we have simplified that. And I sometimes find when students take the square root, they want to hold on to the radical notation, but once you've completed the square root process, notice here that the radical is now gone. So don't keep writing down the radical once you have actually taken the square root. So we're going to be talking about putting some of these things into simplest form. So what is simplest form? It's when the radicand, or the part underneath the radical, has no perfect squares as a factor. And I know that probably doesn't make much sense as you just look at the words, but it will become clear as we look at some of the examples here. So this first one I wanted to talk with you about is the square root of 200. We're going to try and simplify the square root of 200. And I wanted to show you three different techniques for working with the square root of 200, because sometimes your brain goes off in one direction, and sometimes with a different number you may want to try a different technique. So I'm going to look at the first approach, the square root of 200. And I'm going to first break it down into 4 times 50. And I'm going to break it down one more time into 4 times 25 times 2. And of course, I hope you see there that I took this 50 and split it up into 25 times 2. And since I have the perfect squares stored in my brain, because I teach math, I naturally gravitate to those perfect square numbers when I'm simplifying radicals. So I'm going to use one of those rules now. I'm going to take those individual factors and split them into 3 separate radical expressions, and I'm actually going to do the work now. So the square root of 4 is 2. These are connected by times. The square root of 25 is 5. Again, connected by times, and I cannot take the square root of 2 without going into some non-repeating, non-terminating decimal. So I'm going to leave that in radical form. I'm going to go ahead and multiply these numbers together out in front, and then keep the radical square root of 2. So generally, that's the way you want to write this. You put the numbers out in front that come out from under the radical that you can take square roots of, and you leave anything under the radical that you can't take a square root of. So that's approach number 1. So let me take the same example, square root of 200, and show you another way to think through it. So what if I had thought of 100 times 2? Instead of thinking of pieces here. So if I thought of 100 times 2, when I separate this out, you can now see that when I take the square root of 100, this comes out from under the radical, and then of course there's the square root of 2. So you see, of course, we got the same result. We just worked it in a different way. And the last technique is probably the most time consuming, but sometimes it's the only way you can figure out which way to go with it. It's called using prime factors. So you can see me out here creating a factor tree. So I started with 20 times 10. These are both still composite numbers, so I need to break down further. This 20 I took down into 4 times 5. I'm circling the 5 because it's prime. And then you see me splitting the 4 into 2 times 2. And then we come back over here to the other branch. 10 is still composite. I'm going to break it down into 2 times 5. So when I look at the prime factorization for 200, let me check these off. I've got a 2, a 2, and a 2. Let me list all of those. And then I've got a 5 and a 5. So when you're working with square roots, when you get a pairing of 2, those are the numbers that come out in front. So when I take this pairing of 2 times 2, I'm going to pull 1 2 out in front of the radical. I'm going to skip over here and look at this pairing of 5 times 5, keep the times mark in there, and pull out a single 5. And now you see that I have one last piece, which is the square root of 2 that stays under the radical. And of course I end up with the same answer that I got on the other. So 3 techniques. You can look back at these. Hopefully they will help you as we work some of these. I'm just going to do a couple of these with you. Let's take a look at the square root. Let me leave something there so you, well, I can't leave it, so let me just scroll. The square root of 48. And remember, what we're trying to do here is simplify. Okay, so I'm going to try and simplify the square root of 48. Notice that it starts out in radical form, and for answer purposes, if it starts in radical form, you probably want to leave it in radical form. That'll make sense as we get a little further along. So I'm going to look at 48, and I'm trying to think of some numbers, and the first numbers that pop into my head are 4 and 12. Those multiply to give me 48. And of course, 4 is a perfect square, so that's good. But 12, I'm thinking I can break it into another couple of pieces here. So I'm going to take the 12 and break it down into 4 times 3. And again, where that's coming from is I'm taking this 12 and splitting it up into 4 times 3. So if I follow my rules, splitting this up now into 3 radicals, I hope you see, let's see if I can squeeze it in here. The square root of 4 is 2. Here's a times multiplier. The square root of 4 is 2. Here's a times multiplier. And of course, the 3 stays under the radical. So multiply these 2's together and come up with a simplified form, 4 square root of 3. Notice I started in radical form and I'm ending in radical form. All right, so let's try the square root of 63. Trying to simplify it. 9 times 7 comes to my mind. And again, using that rule for working with radicals, I can split this apart, take the square root of 9 to get 3, and leave the square root of 7 under the radical. And I only want to do one more of these. I'm going to do this one in the lower right corner. Notice there's a negative out in front, so this is the negative square root. I'm going to keep that negative out in front and split this up into 2 separate radicals, just like that rule told me I was allowed to do. And I'm going to take the 125 and I'm going to split that up into 25 times 5. And I'm going to go ahead and take the square root of 100. I know that that's 10, so I can go ahead and remove that radical. And then the last step, I think, well, it may not be the last step, the square root of 25. Let's go ahead and put that step in there where we separate this out. The square root of 25 is 5. The radical stays with the square root of 5, and then I have a 10. And now I see one more thing. I remember now why I chose this example to work with you. Notice this whole number 5 and this whole number 10. Those can be simplified So when I finish this up, don't lose the negative out in front. Let me scoot it up so you can see a little better. Don't lose the negative out in front. You could write this 1 times the square root of 5, but generally you don't write that. And then we've got a 2 left down here in the bottom. Okay, so that's simplifying. Let me show you how to simplify when you have variables in the expression. And I'm going to skip down here and talk for a minute, and then we'll come back and work a little bit. To find the square root of an expression with even exponents, divide the exponents by 2. For example, let's say we're trying to take the square root of x to the 4th and y to the 6th. There is an understood 2 index out there when you're doing a square root. So what we're going to be doing here is we're going to take that 4 and divide it by the index 2. And we're going to take this 6 and also divide by the index 2. And we're going to end up with x squared and y to the 6th. Let's do one more example before we go back and start to work. To find the square root of an expression with odd exponents. These were even exponents. These are the easy ones. Odd exponents, factor the expression into 2 terms, one with an exponent 1 and the other with an even exponent. So for example, let's say we're doing the square root of x to the 15th. That's an odd exponent. So what you want to do with that is to break it down, and I hope you remember your exponent rules here. You want to break this down into one term with an exponent of 1, so here you see x to the 1st, and the other with an even exponent. So why did I go to 14? Well, I've got to be able to account for 15 factors of x. So as I split this apart, you can see I'm going to take this index 2 and divide it into that even exponent. Let me write that down. So that's going to be 14 divided by 2. And then this part, the square root of x, just stays in radical form. So that's the way you're going to work with them when you have an odd exponent. So let's go back and do a couple of these at the top. I'm not going to do many of these. We're doing a square root here. How do I know that? I know that because I don't see anything written in the index. When it's left blank, you understand it to be a square root. So again, you can start to do these things mentally. I'm going to split this into the square root of 16 and the square root of y squared. The square root of 16 is 4, and then remember this 2 divides into that 2, and we end up with y to the 1st. And of course, you don't have to write down that exponent 1. And I wanted to do this one here in the lower corner, the square root of 81x to the 4th. So again, I'm separating it. You can do this by hand or you can do this in your mind. And the square root of 81 is 9, so that 9 is going to come out in front as a whole number. And then I'm taking this index 2 and dividing into that 4 and getting 9x squared. And I hope you remember when we originally started this, the reason that's true is if you take 9x squared and multiply it by itself, it brings you back to this 81x to the 4th, which is what you should always be able to do with these, is get back to that original radicand. So those were even exponents. Let's scroll down and do just a couple that have odd exponents. Yeah, here we go. So we're taking the square root of 64x to the 5th, y to the 1st. And I'm going to separate this out. Notice how I even separate out the letters. And here we do the pieces. So the square root of 64 is 8. Uh-oh, this is an odd exponent, so I need to split this into x to the 4th and x to the 1st. Remember we said we would use this so that we had one of the variables with an exponent of 1, and then this other one was going to be accounting for these 5 factors of x. So I'm almost done. I've got the 8 out in front already. Let's do the square root of x to the 4th by dividing this 2 into that 4. And then I've got an x to the 1st and a y to the 1st that are both going to stay underneath the radical. So that one's fairly complicated. Hopefully not too bad. Let's do one more of these. Oh, this was the one I wanted to do. Yeah, this is here. I'm about to get lost on my page. So the square root of 18, a to the 4th, b to the 6th. This one's going to be easier because these are both even exponents. So I think I'll split up the 18 into 9 times 2. And then here's a to the 4th and the square root of b to the 6th and the square root of a to the 4th. So I'm seeing here, let me split it one more time. I hope you see that square root of 9 is going to be 3. The square root of 2, I'm not going to be able to simplify. This, I'm going to do the division, and this, I'm going to do the division. So let's see if I can get it all written down, and then I'll actually execute. Square root of 9 is 3. Can't do anything with the square root of 2, but leave it under the radical. Dividing this 2 into that 4, and dividing this 2 into that 6. So a nice, neat way to write it would be to pull all of these non-radical components in front, and then generally the rule is that we leave the radical expression occurring last in the expression. Okay, so I wanted to do, let's see, I want to do the ones with the cube root. So let me come down a little bit further, and we'll talk about how you work on this with cube roots. And again, we're looking for simplest form when the radicand has no perfect cubes as a factor. And I'm going to be talking about several things at once here. So switch gear, we're not doing square roots anymore, we're doing cube roots. So I'm going to be trying to think of perfect cubes for simplifying. All right, so as I'm looking at the cube root of 54, I'm thinking of 27 times 2. Yep, that works. That gives me 54. And then I'm going to just write down this x to the 6th. So splitting it up, notice now I'm working with a cube root, so I have to keep writing that little index number 3. And then we'll put all the pieces together. The cube root of 27 is 3. I cannot simplify the cube root of 2. And then now, where I divided by 2 on those square roots, now I'm dividing this 6 by that cube root index of 3. So let's see what I've got here. I've got a 3 out in front. I'm sorry, I don't have a good place to put this. Let me come down here into this next problem. So the 3 is coming from here. This is x to the 6th divided by 3, which is x squared, and then the cube root of 2 is going to be the last thing that I write down. So only one more of these to show you. I wanted to show you one where we've got a negative, because we can take cube roots of negatives. So I'm thinking about 40, how I want to split that up, and I'm thinking negative 8 times 5, and I chose 8 because it's a perfect cube. And then this is an x to the 4th, so I'm going to split it into an x cubed x to the 1st. Doing that same thing of doing something with an exponent of 1. And this y 13th, I'm going to split it up into y 12th and y 1st. So again, you'll notice that I'm working really hard to make sure I track these exponents. I'm accounting for 13 factors of y here, and I'm counting for 4 factors of x there. All right, so splitting it up, I'm going to try to do this all at once. The cube root of negative 8 is going to be negative 2. I cannot simplify the cube root of 5, so I'm just going to write that down for a second. When I take this 3 exponent and divide it by that 3 index, I get 1. There's a cube root of x that I cannot simplify. I'm taking this 12, dividing it by 3, and that's going to bring me to y to the 4th. Notice the cube root radical is gone, and then I cannot simplify the cube root of y to the 1st. So we need to put it all together here to get it in a nice looking form. These things that are out from under the radical, I'm going to put those out front. That's the customary way to write it. So I'm going to write the -2, the x, and the y to the 4th, and then 1 cube root radical, the 5, the x, and the y are going to stay up underneath all of that. And I think that's probably a good place to stop. These got a little complicated at the end, but I hope that that is enough to get you started on your own.